Now let us consider some simple problems involving height above the surface of the earth and depth below the surface of the earth. To start with, in the first problem, we have got three positions A, B and C. A is on the surface of the earth, B is at a height 1% radius of the earth, and C is at a depth 1% radius of the earth. Now we want to find the order in which their accelerations due to gravity change. Suppose A is at the surface of the earth, therefore the acceleration due to gravity is g. Now let us consider point B. Then to find the acceleration due to gravity at a height h, we have to use the formula gb is equal to g bracket 1 minus 2h by r. Why we are using this? Because h is very small when compared to the radius. And substituting in this one, it is h is 1%, 1 into 2, 2%, 2% decrease will be there. Therefore, gb is equal to 0.98 g or 98% g. To find the acceleration due to gravity at C, we have to use the depth formula. Gc is equal to g bracket 1 minus d by r. D is 1% of the radius. So Gc is equal to 99% of g or 0.99 g. Now let us arrange them in the order. If the Ga is 100, then Gc is 99, Gb is 98. So Ga is greater than Gc is greater than Gb. If you have got bodies at these three positions, then weight at A will be greater than weight at C, that will be greater than weight at B. Now let us consider big height and big depth. To start, for example, let us consider a point B at a height r by 2 and a point C at a depth r by 2. Let us find the acceleration due to gravity. Since A is at the surface, Ga is equal to g. To find Gb, we have to use the formula Gh is equal to g bracket r by r plus h whole square. Here h is r by 2, r plus r by 2 is 3r by 2, so that will become 2 by 3. R will get cancelled. On squaring that, it will be 4 by 9. So the acceleration due to gravity at g is 4g by 9. 4g by 9 is 0.44g. Now let us consider the point C. Here we have to use the formula Gc is equal to g bracket 1 minus d bar. We know that this formula is valid for all values of d small as well as large up to d is equal to r. So then substituting d is equal to r by 2 here, g bracket 1 minus r by 2 by r, that's equal to g by 2, that is 0.5g. 0.5g is greater than 0.44g. So the sequence is Ga greater than Gc greater than Gb. So you consider this problem and this problem. Don't be under the impression that this pattern follows every time. Need not be. Now let us consider height equal to d, which is equal to 3r by 4. Then A is at the surface, Ga is equal to g. Gb is equal to g bracket r by r plus h is 3 by 4r whole square. 1 plus 3 by 4 is 7 by 4. This 4 will go to the numerator. R will get cancelled. 4 square is 16, 7 square is 49. So this is 0.32 g. Now let us consider point C, which is at a depth r by 2. Which is at a depth 3r by 4. Then this will become g bracket 1 minus 3r by 4 by r. That is 1 minus 1 by 4. 1 minus 3 by 4, that's equal to g by 4, that's equal to 0.25g. Here you can see that Gc is less than Gb. So the sequence is Ga greater than Gb greater than Gc. Here what we had earlier, Ga greater than Gc greater than Gb. Here it is Ga greater than Gb greater than Gc. Our weight at A will be more than weight at B, that will be more than weight at C. That means same sequence need not be there every time. Let us consider another interesting problem. We have got point C at a depth d, which is equal to twice the height of the point B. Then Gb is equal to g bracket 1 minus 2h by r, and Gc is equal to 1 minus d by r, but d we are taking as 2h, so this is 1 minus 2h by r. So you can see that Gb and Gc both are equal. Only Ga is greater. GA is greater than GB is equal to GC. I hope it is clear to you.